Hello friends, this video on mechanical properties of fluids part 10 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to 9 before going ahead with part 10. We will now study Pascal's law for transmission of fluid pressure. So before this we have already studied Pascal's law. So what was Pascal's law? It was for uniform fluids which are confined. The law stated that when we apply a pressure to such fluids, the pressure is distributed uniformly in all directions by the fluid at the same rate. Now let us see what is Pascal's law for transmission of fluid pressure. It says the pressure exerted anywhere in a confined, incompressible fluid is transmitted undiminished and equally in all directions throughout the fluid. So if you see, both these Pascal's law and Pascal's law for transmission of fluid pressure are almost similar. I mean, they are very much related. This law states that if we consider a confined fluid, that means a fluid which is restricted within a specific region in space, and if the fluid is incompressible. What do you mean by incompressible? A fluid which is not reduced in volume by an increase in pressure. The term incompressible, that is incompressible, something which cannot be compressed. That means something whose volume does not changes, or the volume does not get reduced even if you apply pressure. So if you have an incompressible fluid which is confined, when pressure is exerted on such a fluid, it is transmitted undiminished. Undiminished means without being reduced. The term diminish means small. That means without becoming small. That means the amount of pressure which you exert, the equal amount of pressure will be transmitted by the fluid equally in all directions throughout the fluid. So basically the law remains the same, just that the way of expression changes. So this law is more popularly known as Pascal's law for transmission of fluid pressure. Let us look at the same example. We consider a circular vessel with 4 openings as shown in this figure, and along these 4 slits we have placed 4 pistons which are movable. So what happens when this piston A, let us call this piston as A. When piston A is moved downwards, a pressure is exerted in this direction on this liquid. So this pressure gets transmitted in all directions equally. That means the amount of pressure that is exerted here, equal amount of pressure gets exerted along all the directions, because of which all these pistons, all the 3 other pistons are moved outwards, and they move equal distances outward. That means the equal amount of pressure is exerted in all directions. Right? Okay. Now we will look at some applications of Pascal's law. The law which we studied just now, it has got very many wide applications in day-to-day life. The first application which we will study now is the hydraulic lift. What is a hydraulic lift? As the name suggests, hydraulic, that means a lift which makes use of water. The term hydro means water. So hydraulic lift is nothing but, it is basically a lift which is used to lift vehicles. Like you would have observed it when you give your cars or your vehicles for a wash. I mean, there are places where you go or where you contact for your car wash. So what do? You would have observed that there is a kind of platform where the vehicle is placed, and then the vehicle is lifted in this way, right? So it is basically a lift which makes use of water. So what will we see here is the principle behind these kind of hydraulic lifts is nothing but the Pascal's law. So do you know how does this actually work? The internal setup is somewhat like this. This is basically a rough diagram which will explain you how it works. Inside this hydraulic lift, the principle inside this lift is somewhat like this. There are two platforms which are created. One is with a smaller area, this one, if you see, and the other one with a comparatively larger area, right? So, and this entire setup, this is basically nothing but a tube kind of a structure which is filled with a fluid. So, there are two pistons which are attached here and here. So, pistons means we can apply force here and we can move the pistons along this surface. Along this neck of the tube, the piston can be moved. Similarly, along this neck of the tube, the piston can be moved. So, two pistons are separated by space filled with a uniform fluid, and in this space, some uniform fluid is filled. So, you have a fluid which is filled in this entire space. These are the two pistons. Let us call them P1 or let us call them piston 1, and this is piston 2. So, these are the two pistons. So, this piston 1 has cross-sectional area. This cross-sectional area is A1. For this piston 2, the cross-sectional area is greater. Let us say that is A2. Now, if we apply a force F1 on this piston, we apply a force F1 on this piston. See, this is a piston of a very small area. So, we can apply a comparatively smaller force. What happens when you apply a force here? This pressure gets exerted in this direction. Through this uniform fluid, according to Pascal's law, the pressure gets transmitted equally in all directions, and the same pressure gets exerted here. So, the same pressure gets exerted, and as a result, this piston moves outwards. So, what happens? This piston in turn is connected with the platform on which the vehicle is placed. So, what happens? The vehicle is lifted upward. So, what was the advantage of this method? The advantage is that since it has this side had a smaller surface area, we had to apply a very small force. With a very small force, we were able to exert a larger force on a larger area and lift the vehicle. Imagine if you would have not applied the force on this surface area, and if you would have directly tried to pull the car, if you would have directly tried to lift the car, it would have been a very tedious job, because you would have been required to apply a very greater amount of force. But in this case, since you applied it over a smaller cross-sectional area, even a small force was enough to move this piston. And since the fluid transmitted the pressure without reducing it, so the same pressure was able to lift the larger cross-sectional area piston outward, and as a result, the vehicle was easily lifted. So, what did we observe here? So, we applied a force F1 on this cross-sectional area A1. So, as a result, a pressure was exerted. Let us say that pressure is P. That pressure P is exerted. Now, what happens here is, this resulted in a force on this area A2. Let us say this resulted in a force, say F2, along the larger cross-sectional area piston. So, what did we see? However, the pressure remained the same here also. So, what did we see? We see that the resultant force was F2. So, F2 was nothing but the pressure P into area A2. What was the pressure P? Pressure P was created due to F1, that is F1 by A1 into A2. So that is equal to A2 by A1 into F1. So what do we observe? We observe that because of this setup, the applied force was increased A2 by A1 times. That means we applied a force of F1, but what was the result of that? Our input, the input from our side was F1. But what was the output? The output was A2 by A1 into F1. This was the output. So that means we had to do nothing to increase the applied force. We applied an input F1, but we got an output which was A2 by A1 times F1. That means our input was multiplied. Our input was magnified. So that was only, and that happened only because of this Pascal's law, because we were able to apply Pascal's law in a correct way. So we had to do nothing, but we applied a smaller force and we got an output of a larger force. So this hydraulic lift, so please understand very clearly how does a hydraulic lift works, because the same principle applies to many other applications as well. For example, the hydraulic brakes. We will study hydraulic brakes just after this. So I hope you understood what is the advantage of Pascal's law and how is Pascal's law applied in such scenarios like hydraulic lift. Now, thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.